In this video, we are going to talk about implicit differentiation. Now, what is an implicit differentiation? Up until now, we had an equation with only one variable. For example, last section, we learned something like 6 times x squared minus 3x plus 12 raised to the 6th power. One variable. All the x term is on one side. Now, this format is called explicit because you have an equation solved for y and then you only have one variable. However, sometimes the equation might not have only one variable. So here's an example of explicit equation versus implicit equation. So let's say you have these two equations, 3x squared plus y minus 2 equals 0 versus y is equal to 2 minus 3x squared. This is what we normally saw, and then we took the derivative, right? So this part is a 0 minus 6x, right? So this equation, we call it explicit because it's explicitly written. Because we have equation y written as x. This enables us to determine y for each value of x, and then we were able to take the derivative for here. Now this equation here have both x and y involved. This is implicitly written. This equation can be rearranged and solved for y, then you get, let's say you add 3x squared plus y equal 2, and then subtract 3x squared, which is what we have on the right hand side. So you can see that they're the same. But this part over here, when we had x before the rearrangement, x and y term together, it's written implicitly because y is written with the x. Now, sometimes it's better to take the derivative on this because we have seen an equation where sometimes solving for y can be difficult. Let's say something like this, right? Where we have, where we have this type of equation. It's very hard to find the y by itself because you need to put all the x term and then put y term, but there's a ln of y. So it's kind of hard. It's almost impossible to solve for y. So we cannot really take the derivative. So implicit differentiation is used so that when we have an equation that we cannot solve in y, we can still take the derivative as it's written. Okay, so let's go through the procedure. Now the procedure looks a little bit long and kind of messy, but as I go through the example, I'm gonna follow those step by step. Okay, so rather than for me to just read through all 5 steps, I'll use the example and then check off step 1, step 2, step 3, and so on. Okay, so let's take a look at very first example. We have an equation 7x squared plus 5y minus 21 equals 0. Now, first way, I'm going to do like what we normally did. We have an equation written as y and then take the derivative. Second way, I'm going to actually take the derivative as it is. Now, a and b, when you take the derivative, it should give you the same result because we are working with the same equation. We just approach 2 different ways. So you're gonna get both same answer after you take the derivative. So the derivative function is the same, but we are just approaching differently. Okay, so let's do the kind of like first one, traditional way. So I need to rewrite this equation so I have y by itself so we can take the derivative. So if I have 7x squared plus 5y minus 21 equals 0, add 21, 7x squared plus 5y equal 21, subtract 7x squared. So I have 5y equal negative 7x squared plus 21 divided by 5. I have y is equal to negative 7 over 5x squared plus 21 over 5. Now, once I have the equation here, taking derivative is easy. So y prime, I'm going to take the derivative. Notice that I put y prime because that means I'm taking the derivative of a function y. So this part over here, bring down the power and then subtract by 1. So negative 14 over 5 x, and then last one is a constant, so this is it. Okay, that's what we normally did. We rewrote an equation explicitly and then take the derivative. Now, we are going to do implicit differentiation. So we are going to not solve for y, just begin as it is. So here's the step. Find the derivative of a function using the rule y prime or dy dx, up to you which notation you use. So just like this, first term, well, let's bring down the power, so 14x. Now here's the key thing about implicit. This is a y term. Notice that when we take the derivative of a y term, we use a y prime. So same thing happens. You're gonna take the derivative and then notate that I took the derivative of y, so we are gonna use y prime. So what is the derivative of 5y? If we just look at if I ask you to take the derivative of 5y, that's just 5. So we put 5, so that's my derivative, and you wanna put y prime. You have to put that notation because that's the way that I am letting people know that I took the derivative implicitly. Just like over here, y didn't get disappear. I just use y prime because I'm going to take the derivative. So I took the derivative of 5y, which is 5, but y prime is attached because I took the derivative of variable y. Constant in general disappear. Same thing on the right hand side, disappear, right? So plus 0 and then 0. These are the constant derivative. And then all we have to do, so step two says remove parentheses. Well, we don't have a parentheses, so we skip number 2. Group all the y prime on one side, and then we solve for y prime. Okay, so I'm going to move everything and solve for y prime. So negative 14x, 5y prime equals negative 14x divided by 5 divided by 5. So I have y prime equals negative 14 over 5x. Okay. All right. And you see that we get exactly same result. One, we use explicit. Second one, we use implicit. Okay. So that's what we are going to be practicing. We are going to do in this section implicit function and take the derivative. Okay, because these are doable by solving y and then take the derivative, but sometimes you might not have always a nice function where you can solve for y. So let's go through a couple more examples. Use implicit differentiation to find the first derivative. So I'm going to find the y prime and evaluate it at a given point. And then I'm going to take this y value and then I'm going to take the y prime function and then evaluate at that given point. So let's take a look. So term by term, I need to take the derivative. Now I noticed that there's 2 y terms. So both terms should have a y prime after you take the derivative. Now first one, 5xy squared, that's kind of like our product rule. There's 2 functions being multiplied because x and y is a different variable. So now you have to separate them. Those are the 2 different variables. So I'm kind of going to use colors. So I'm going to have 5x term multiply blue term. So recall product rule, right? So we have first term as it is, right? We kind of rotate. So first one and then second one prime, and then add second one, second term as it is, and then first term prime, correct? So let's do that. So that's gonna be my derivative parts. So 5x, now derivative of y squared is 2y, but here's where the implicit part comes in, y prime. Noting that I took the derivative respect to y, plus, just as it is, y squared. This one, you do not need a y prime because this is just, I didn't take the derivative. And then derivative of 5x will be 5. Now let's move on to the second term, which is 8y. 8y, derivative of 8y is 8, but it's variable y, so I need to put the notation y prime. Now the last one, negative 3x squared, the normal basic rule, so negative 6x. And then on the right hand side, derivative of 0 is just 0. Now here, notice that I did not put anything attached. I didn't put x prime here because think about this. When we do this one, when we take the derivative of this one, we never notated x prime. Because this was already taking, this means that I'm taking the derivative of a function y respect to x. So you do not need the x prime. So same thing, I didn't put x prime even though I took the derivative. So number 2, remove parentheses if necessary. So I'm going to remove all these parentheses by multiplying. So this will give me 10xy y prime 5y squared 8y prime minus 6x equal to 0. Step 3. Let me erase this one. Step 3 says group all y term on one side. So I'm going to have these two on one side and then move these two on the other side. So let's do that. I'm going to subtract 5y squared, add 6x. That means I have to do that. Negative 5 y squared plus 6x on the other side. So these two disappear. On the left hand side, I have 10xy y prime plus 8y prime equal to negative negative 5y squared plus 6x. All right? Now let's keep going. Next part says factor y prime and then solve y prime by dividing. These two have a common term, y prime, so I'm going to factor that out. Then I have 10xy plus 8, right? When you distribute, you get back to this. And then on the right-hand side, I have a negative 5y squared plus 6x divided by 10xy plus 8 divided by 10xy plus 8. So I have y prime equal to negative 5y squared plus 6x over 10xy plus 8. So that will be my first derivative. So this is my first derivative. But we want to evaluate this given point. So that means I'm going to take one more step and then take this and plug it in. So this will be my first derivative. We have a point 1, 4. So that means 1 is my x value and then 4 is my y value. So I'm going to plug it in. Wherever you see x, I'm going to replace it with 1. Wherever you see y, you're going to replace it with 4. So let's find out our function value. So y prime end up being negative 5 4 squared plus 6 times 1, 10xy plus 8. Okay, so I have negative 5 times 4 squared. So that will be, let's check with the calculator, 16 times 5, negative 80 plus 6. And then you have 48 on the bottom. So you have negative 74 over 48. Or you can change to the decimal number. End up being 1.5417 rounded to the 4 decimal place. Okay. All right, so that's the whole process of implicit differentiation. And notice that this is it's not too bad because we are taking the derivative for entire function. Imagine trying to solve this equation into y, then you're gonna end up having square roots and we don't know how to take the derivative of those messy functions. So implicit differentiation is very nice because it deals with the term by term. Okay. So let's take a look at another function. Now this one has natural log and exponential function. So, but you do exactly the same. So I'm going to take the derivative for each whole equation. Wherever you see the y term, we are going to notate the y prime. So this one requires y prime and this one requires y prime after you take the derivative. So first, what is the derivative of 7ln? This one will be just 7y because derivative of ln y will be just 1 over y, but we have a 7. But do not stop there. You need to have y prime notation because we took the derivative. E to the x derivative is just e to the x. Derivative of 4x squared, that will be 8x. And then we are going to have negative 6y prime, right? Derivative of negative 3y squared is negative 6y, but it's a y term, so we have a y prime. So we took the derivative of whole thing, okay? So you have to take the derivative of whole entire terms. Now let's rearrange. So I'm going to put all the y prime term first. So I'm going to move this one over here. Then I have 7 over y prime plus 6y prime on the left hand side, e to the x plus 8x. So that is step 2. Step 3, I put all the y prime on one side. Step 4 says factor out y prime and then divide by y prime to solve. So factor out y prime since they both have a y prime term. Then I'm going to have 7 over y plus 6y e to the x plus 8x. And then divided by 7 over y plus 6y divided by 7 over y plus 6y. So I have y prime equal e to the x plus 8x over 7 over y plus 6y. And that's it for the derivative part. But they ask you to evaluate, so I'm going to use 0, 3. This is my x, this is y. So my whole entire value is e to the 0 power plus 8 times 0. 7 over y, which is 3, over 6 times 3. So I have e to the 0 is 1, so 1 plus 0, so 1. 7 over 3 plus 18. Okay. So this will be 7 over 3 plus 3 times 18 times 3, 54. So I have 1 over 61 over 3. So complex fractions, which is equivalent to 3 over 61. So this will be my first derivative. Evaluate the given point 0, 3. Okay. All right, here's the last problem. Find y prime and the slope of a tangent line to the graph of an equation below at indicated point. So this is just on this wording, do not get confused, but it's exactly the same as this part over here. Implicit differentiation to find the first derivative and then evaluate. Because slope of a tangent line is your y prime and they want you to evaluate. So number 4 is the same thing as number 3, but they just word it differently. You guys have to feel comfortable seeing a written instruction differently, but it means exactly the same. Okay, so I'm going to do the implicit differentiation. With that function, I'm going to evaluate 3, 2. So let's do, you can see that in this function, you have a square root function involved. So I'm giving you variety of different example. Also, this looks very similar to homework number 11, 3.5, number 4. So you can use this one to help you complete some of the homework problems. So for me, I don't like the roots, so I'm not gonna do the derivative yet, but I'm going to rewrite this here as a 1/2 plus 5x squared plus 13 equals 0. Okay, now if you look at this one, this first term have y term, so I'm going to have y prime involved after I take the derivative. Now, if you look at this one over here, this term requires chain rule. Last section, you have something inside of square root function. So when you take the derivative of this first function, I'm going to use chain rule. And recall chain rule, last section, it was if you have f of x as g of h of x, then f prime of x is g prime hx times h prime of x. Okay. All right, so let's do some implicit differentiation. So I'm going to take this whole thing and then take the derivative for entire equation. This term, this term, this term, this term. Okay, so the first one, if you want to, you can use it on the side. We have 2y cubed minus 16 raised to the half. So my g function will be x to the 1/2. My h function will be 2y cubed minus 16. Everybody follow that part? Okay. So g prime of x will be 1/2 x raised to negative half. H prime of x will be, now if you take the derivative of this one over here, I'm going to have 6y y square y prime, and this one disappear. Notice that I attach y prime because I'm doing implicit differentiation. So my function derivative of this term will be g of h of x times h prime of x, so which will be 1/2 2y cubed minus 16 raised to negative 1/2 times 6y squared y prime. So that will be my derivative for my first term right there. So let me rewrite it. So 1/2 2y cubed minus 16 negative 1/2 6y squared y prime. Now let's do a middle term. Okay, so I'll color code it so you guys do not get confused. 5x squared, that's 10x. Easy. Okay. And then the last one, the 13, derivative of 13 is just 13. 0. Okay. And then derivative of 0 is just 0. So we are all done taking the derivative. Okay. Second part is to rearrange and have y prime term by itself. So I'm going to keep this one and then remove everything on the other side. So that means I'm going to be subtracting 10x. So 1/2 2y cubed minus 16 negative half 6y squared y prime equal negative 10x. Now I need to move everything except y prime. This is a multiplication, so I can divide the whole thing except y prime. So 1/2 before we do that, let's do a little bit of a simplifying, right? So we are on this one. And then, so here I can reduce this 2 with 6, 3. I cannot reduce this 2 with this one because it's inside of parentheses. Common mistake is this, but this is inside of square root. So I have 3 y squared times 3y cubed, 2y cubed minus 16 to the negative half y prime negative 10x. I did some arrangement so it's easier for me to see what to divide. So divide this whole thing, right? 3y squared 2y cubed minus 16 raised to negative half 3y squared 2y cubed minus 16 raised to negative half. So y prime end up being negative 10x 3y squared, and then we have 2y cubed minus 16 to the negative half. But I don't like negative half, so I can move it on the top to make it positive exponents. So let's do that. On the next page, this is what we have. So moving it on top to make a positive exponent, I'm going to have y prime equals negative 10x 2y cubed minus 16 to the 1/2 all over 3y squared. And this will be my differentiable function, first derivative, implicitly. Now we need to find the tangent line at a graph of equation on indicated point. So 3, 2. So let's put that 3, 2. So that's your x, this is your y. So y prime equals negative 10 times 3. 2 times 2 cubed minus 16 raise it to 1/2 over 3 2 square. So y prime equal negative 30. 2 cubed, that's 8, so 16, so that's a 0, raise it to 1/2. 4 times 3, 12. So here, 0, square root of 0 is a 0, so negative 30 times 0 is a 0 over 12, so equal to 0. So y prime equal 0. So slope of a tangent line to the graph at the given point 3, 2 is 0. Okay, that's it for section 3.5.